What's up guys, we're going to be taking a look at this lab, authentication bypass via information disclosure. There are two aspects to this, an authentication bypass, but in order to perform that bypass, we need a piece of information that's disclosed to us. And that piece of information in this case is a custom HTTP header. So we're here on the home page and we notice that there is a link to the admin panel and it takes us to the root /admin, but we get the message admin interface only available to local users. So we might guess that there's some form of perhaps IP-based protection. The app is really looking for connections potentially from the local host, but it's not clear how that information is being communicated to the backend. So here in Burp Suite, we can see a copy of the GET request that was sent to the backend, and we can see that same message, admin interface only available to local users. So it's here that we find the information disclosure, and it's by changing our HTTP verb from trace to get. Now the idea with the trace method, it's really for troubleshooting, and it's going to reflect the HTTP request back to us that was received by the final endpoint. So let's send this to the backend and we can see a copy of our HTTP request which finally hits the application. Now the thing that we should notice straight away is that the HTTP request that hits the application ultimately is different from the HTTP request that we've dispatched from the browser. We have additional headers in the request that reach the application, including the custom header xcustom IP authorization, followed by our global IP address, which I've obfuscated, but in most cases it's not a huge problem if someone has access to your global IP address. Now it turns out that if we add our own version of this custom header and we specify an IP address, let's set it to localhost 127.0.0.1. Let's send this as a trace request and we can see that the header that ultimately hits the application involves that localhost IP address 127.0.0.1. So although this header is appended to our HTTP request at some point, if that header already exists, then no changes are made to our HTTP request. So the information disclosure here is the name of this custom header. We would not have guessed this, but the information has been disclosed to us. Now we might wonder why this is information disclosure. Is this actually a vulnerability? The reason why it's potentially considered a vulnerability here is because most web servers disable trace request in production. And it's for this kind of reason, if there are modifications made to the HTTP request, those modifications should not necessarily be available to the end user. So there are certain security implications with leaving trace HTTP requests available as part of the web app. So in this case, trace probably doesn't provide any additional functionality to the web app, but it does potentially create security problems. So it's usually considered best practice to disable trace on a web server. Now, this in itself, although it's information disclosure, it's not a vulnerability just yet. So what? We know the name of the custom header that's being used, but that doesn't automatically mean that there is an authorization bypass vulnerability. We know from the title of the lab that it exists in this case. What we're going to do is simply change our trace request back to a GET request. We're going to send that to the backend. And when we look at the rendered HTML, we can see that rather than get the error message, we're now actually fully accessing the admin panel. In other words, we've bypassed authorization by setting this custom header. The web app is only accepting requests from localhost, but it's deciding whether or not we're localhost based on this custom header. So the application receives a HTTP request, it looks for the xcustom IP authorization header, it sees that it's set to 127.0.0.1 and says, okay, this is an internal request. This must be an admin. I'm going to serve admin pages. Also allow admin requests. For example, we have two routes here to delete various users. The objective of this lab is to delete the user Carlos. And if we have a look at the HTML, we can find out where these routes are. So to delete Carlos, we have /admin delete and then part of the query string username equals Carlos. All we actually need to do is change where the request goes. So if I copy this route and instead of /admin, I visit admin delete username equals Carlos. So long as I have this custom IP authorization header in place, it's going to delete the user Carlos. The lab is going to be solved. Now, it's completely fine to solve the lab this way. However, this is only practical because we only need 2 requests to solve the lab. The first one to access the admin panel, and the second request is to visit the route where Carlos gets deleted. So it's fairly trivial just to send 2 requests with an additional header that's been added manually. But let's imagine that you don't know what the vulnerability is yet. You want to send lots of HTTP requests, and furthermore, you want to browse in your browser with all of the HTTP requests having this custom header appended. The way to do that is heading to Proxy tab, Proxy Settings, and we have HTTP match and replace rules. Now, I actually created one of these earlier, so I'll just go to edit so we can see what it looks like. Type request header. Match field is left blank. It says there, leave blank to add a new header. And then we are going to add the header X custom IP authorization 127001. Now, the only thing we really need to change, since I made this previously, is just to check the checkbox to say that this particular match and replace is enabled. Now, if I reload the admin page, in the background, that request is hitting the proxy first, i.e. Burp Suite. It's then appending that custom header before the request is being sent to the web app. So now we're being authorized as an admin because from the web app's perspective, based on the check that it's running, we're actually originating from the local host. And that proxy addition of the header is going to continue as I visit additional routes. So I can continue to navigate this web page as admin, including making use of these links. So if I click the delete link, that custom header is going to be added automatically. And we can see we get the message, user deleted successfully. Congratulations, you solved the lab. Now, in a way, the big vulnerability here is really the authentication bypass. So we shouldn't have some kind of authentication system that's easily spoofable. But the authentication bypass realistically would not have been discovered if it wasn't for the information disclosure of that custom header. So a key takeaway from this particular lab is unless you actually need trace for something, which is fairly unlikely, you may as well disable trace HTTP requests in production. The other thing to consider here is there is really not a big reason for the authentication via the custom header. It may serve some very specific use cases, but significant security vulnerabilities can potentially be introduced as a result. In other words, we could just be authenticating here with an admin username and password, and it's going to be more secure than a spoofable custom HTTP header. All right, hope you found it interesting. Thanks very much for checking out the content, and I'll catch you guys in the next lab.